Lesson 9.3, Transformations of Quadratic Functions. In this video, you will learn to apply translations of quadratic functions and apply dilations, reflections to quadratic functions. Vocabulary is transformation, translation, dilation, reflection, and vertex form. So, translation is when you have a graph, we're talking about quadratics, so we're talking about parabolas, and then you move it. So we could maybe move it over further this way, or move it down, or maybe it's a combination of the two, but that's a translation. Dilation is when you start out with your original, and you make it either narrower, so it can come and do this, and it gets narrower, or it could get wider, like that. Okay, a reflection is, so if you start out like this, your graph starts here. A reflection down here. All right, and so we're going to talk about these in this lesson. So the first thing is a vertical translation. So if you want to move something up or down, what you do is change what you're adding to x squared. So the blue line that they have here, that's just regular x squared. So if you add something to it, it's going to move it up. If you subtract something from x squared, it's going to move it down. And this is when there's no parentheses. Okay? So the adding and subtracting is applied to x squared, not just to x. And we'll get into this. So we want to describe how this is going to affect this. So if this is our original graph right here, we want to know what we do to it, what's going to happen in the graph if we add 10, right? So if that moves our graph 10 spaces up. So if we started out here, this is our regular graph, and we just shift the whole thing up 2, 4, 6, 8, 10 spaces to get us here. Okay, so that's called a vertical translation. Okay, and the same thing, if I start out with x squared, and then all of a sudden I have x squared minus 8, subtracting 8 from x squared will move the graph down 8 spaces from the x squared. So if we start out with this regular one here, and then I move it down 2, 4, 6, 8 spaces, and then I get the same shape of the graph, it's just shifted down further. Okay, so those were vertical translations. We also have horizontal translations, and those are when you add or subtract inside of the parentheses, and it gets squared, what you're being added or subtracted. So h, it's going to move either left or right. Now, when it's inside the parentheses, it does the opposite of what you might think it would do. So if you said, okay, it's minus h, so that would probably move it that way. You would be wrong. Minus h is going to move it forward h spaces like that. Plus h would move it backwards. Okay, so think opposite of what you're expecting when it's inside the parentheses. Okay, so I want to know what adding 1 inside of the parentheses is going to do to x squared. So remember, plus, it's forward with plus, but it's actually going to move back. So if we started here at 0, the regular x squared graph, we're going to shift it back 1 space, and that brings us to that. Okay, so this moves it that way 1 space. Okay, so same thing with this one. We're minus 4. What is that going to do to my graph? So that it would go to the left, but it's going to do the opposite and move to the right, forward 4 spaces. So it starts here and it goes 1, 2, 3, 4 spaces. And it's the same shape of the graph, it's just shifted over 4. Okay, what if I have both things? So in this case, I have plus 1 and plus 1. The outside of this one moves it up and down. So because it's positive, it moves it up. This one moves it left and right. So because this one is positive, it does the opposite what you would think. You would think forward, it's going to actually move back by 1. So I start here, and I can think of these as points, right? I take each one and I move it up 1 and back 1, and it gets to that point. Or if I take this one up 1, back 1, I get to that point. Or this one up 1, back 1, I get there. Okay, so if you do that to any of your points, you're going to get the new shape of the graph. So this is going to move left 1 space, and it's going to move up 1 space. Okay. This one, describe how the graph of g of x equals x squared minus 2 squared is related to the graph f of x equals x squared. I'm pretty sure this is a typo. Okay, so if we're looking at this, what is this plus 6 and this minus 2 to do the graph? So again, that outside moves up and down. It's going to move it up 6 spaces. And this minus 2 is going to move it forward 2 spaces. So if I'm starting here, I'm going to take this point and I'm going to go up 6. That gets you there. And forward 2 would get me here. And if I took this one, let's see, we'll start here. If I take this one, I go up 6 and forward 2, I get that point. And this one, if I take it up 6 and forward 2, I get there. Okay, so you see that this graph moves it up 6 spaces and right 2 spaces. Okay, so the next one is dilations. These are going to be a vertical stretch or a compression. So if you're thinking about stretching something, if you were to grab your graph and pull this way and this way, it's going to start to look narrower. So this red represents a stretch, right? If you're pulling on something, you think about like a piece of gum and you pull it vertically, it's going to get narrower, it's going to get skinnier like your piece of gum. Okay? If you were to take your same piece of gum and push down on it, it's going to start to look a little bit fatter. So a stretch is going to get narrower, and a compression, if you're pushing down on it, you're compressing it, it's going to start to look fatter. So that would be the green is a compression, and then the red was stretch. Okay? So the way you know if something's going to be a vertical stretch or a shrink is you look at the value of a, the number in front of x squared. Okay? Absolute value of a, not worried about signs, whether it's positive or negative. If the value of a is greater than 1, then that's going to be a stretch. Okay, it'll do this. And if a, the absolute value of a is between 0 and 1, so it's like a fraction that's less than 1, or a decimal, so 0.5 or 2/3, all of those are examples of things that would be a compression. It's going to get a little bit fatter looking, our graph, or wider, a little bit more open. Okay, so I wanted to describe what this is going to do to my graph. So 1 is that greater than 1 or less than 1? 1/3 is less than 1, and it's between 0. It's also greater than 0. So this means that it's going to be a compression. So if I were to graph these two things and start out with my regular x squared, it would look something like this. That's really bad, but if you were to do 1/3 x squared, it would look wider. It would open up more. Okay? So this one, I want to know what is going to happen in this graph from the original. So I, again, start with the original of x squared, which looks like this. And I want to know what I'm going to do to this graph to get this. So I'm paying attention to the two being done different. So what I have different is the 2x squared, so the 2 and the plus 1. So the 2 in front of x squared, this means it's a dilation. And this plus 1 is a vertical translation. So this moves it up 1, and this makes it skinnier because it's greater than 1. So this green, first thing I would do is I would do this. I would make it skinnier a little bit. Oh, I can't draw. Okay, so it gets a little bit narrower. And then the plus one is what moves it up. So I move it up from there. After I shrunk it, it gets a little bit narrower and starts at 1 now. Okay, hopefully you get the idea despite my horrible drawing. Okay, and the last one is a reflection. So if you have negative in front of f of x, so if you make the whole function negative, what that does to the graph is it flips it over the x-axis. So if it was up here, it now becomes down here. Okay, if you have negative inside, so that's like if you're putting in negative x instead of x into all of your functions, then that would be a horizontal flip reflection. So it flips over this axis, which would get you to the same graph. It pretty much doesn't change it too much. Okay, so I wanted to describe what this is going to do. So I want all of the steps. The things that are different. First, we have the negative is going to be a reflection over the x-axis. Okay, if this had been 3 times negative x squared, that's when it would be y, because that negative is applied to the squared. It gets raised to the squared. But because here that negative doesn't, it's going to be over the x-axis. Okay? And then what else do I change? I have that 3. What is 3? Is 3 greater than 1, or is it between 0 and 1? It's greater than 1. So that means that it's going to be a vertical stretch. And it's going to be by a factor of 5. Okay, and then the last thing I want to look at is the plus 1. So that plus 1 is going to be a vertical translation. Remember, translation shifts it up or down or left or right. So this is a vertical translation by 1 unit. Okay, so you guys should be able to look at any equation and see what you're doing to it based off of the original x squared graph. So for this one, this minus 7 shifts it down 7, so it moves it down here. And that 1/5 is going to make it wider. So instead of being like this, it gets wider, like that. Okay, and this last one, which is an equation for the function shown in the graph. So I want to know if the original x squared function, right, if I would just look at this, I have 0, 0, because 0 squared is 0. 1 squared is 2, so I have the point 1, 2. 2 squared is 4, so I would have the point, 1 squared is 1. 2 squared is 4. And then I would do the same thing with, okay, 1, 1, 2, 4. And then negative 2 squared is still 4, and negative 1 squared is still 1. So this is my original graph of x squared, right? So what did I do to this? I moved it down 2 spaces. So that means that in my minus 2. So I'm looking at either this one or this one. Okay? So, and then I want to say, did this get wider or narrower or anything like that? I would say that this looks wider in this one, right? Because in the other one, if I had just shifted these down each 2, my graph would have been more like this. Okay, so this got wider. So that's like a compression, which means that the A value had to be between 0 and 1. So that means that I was looking at either this one or this one. But because it's opening upwards, it's going to be positive. So it's going to be A. And it has both of those transformations also. So my answer for this is 8. And that's the section.